Hello friends, let us now learn some important points about grids. The radiographic grid mainly consists of lead foils that are separated by X-ray transparent spacers. So these are series of lead foils separated by X-ray transparent spacers. So these are the lead foil strips, and these lead foil strips are separated by the X-ray transparent spacers. These are spacers, X-ray transparent spacers. So now this is invented by Dr. Gustav Bucky in 1913, and it is still most effective way for removing the scatter radiation. So if this is the tube anode, so from here the X-rays are produced. This is the patient, and behind the patient or beneath the patient grids are placed. So the X-rays or primary radiation will pass through these lead strips. So primary radiation is oriented in the same axis as the lead strips and passes between the lead strips to reach the film, and thus it is unaffected by the grid. Whereas the scattered radiation arises from many points within the patient, and it arises from many points within the patient and is multidirectional. So most of it is absorbed by the lead strips, and only a small amount of it can pass through them. So this is the lead strips, and the interspace of the grids are filled by either aluminium or some organic compound. The main purpose of this interspace is to support the thin lead foil strips. So the aluminium interspace grids can be manufactured probably more precisely, and they are structurally stronger than organic interspacers. The patient exposures are higher with aluminium, so aluminium absorbs more primary radiation and it also absorbs secondary radiation also. So as a result, it absorbs more secondary radiation also. However, so contrast improvement is better with this aluminium grids. At the present time, both aluminium and organic materials can be used. There is no clear-cut differentiation so as to which is better in the present time. Terminology. First, grid ratio. Grid ratio is the ratio of the height of the lead strips to the distance between them is called as grid ratio. Grid ratio is equal to height of lead strips by distance between the lead strips. So this grid ratio is around 8 is to 1. If the grid ratio is around 8 is to 1, the lead strips are approximately 0.05 millimeters thick, so that they are appropriately to be considered as lead foil. The interspaces between the lead strips is much thicker than the lead strips itself. So the grid ratios are mainly expressed in two numbers. It is expressed as two numbers like 10 is to 1. The first number is actually the ratio or actual ratio, and the second number is always 1. So grid ratio is a parameter used to express the grid's ability to remove the scattered radiation. This grid ratio is usually in the range of 4 is to 1 to 16 is to 1. Higher the grid ratio, better the grid functions. Grid ratio is mainly indicated on the top of the grid by manufacturers. The second terminology is grid pattern. Grid pattern is the orientation of the lead strips in their longitudinal axis. It is the pattern of the grid that we see from the top view. There are two basic grid patterns, that is linear grid and crossed grid. In a linear grid, the lead strips are parallel to each other in their longitudinal axis. Most X-ray tubes are equipped with this linear grids. The major advantage of linear grids is that it allows us to angle the X-ray tube along the length of the grid without loss of primary radiation as the grid cutoff. So it allows us to angle the X-ray tube along the length of the grid without loss of primary radiation from grid cutoff. Then second part is the crossed grid. The crossed grid is made up of two superimposed linear grids that have the same focusing distance. Grid ratio of the crossed grid. So these two linear grids which have the same focusing distance. Grid ratio of this crossed grid is the sum of the ratios of the two linear grids. A crossed grid made up of two 5:1 linear grid has a grid ratio of 10:1 and it functions same as the linear grid of 10:1. The disadvantage of this crossed grid is that these crossed grids cannot be used with oblique techniques requiring angulation of the X-ray tube, which is the biggest disadvantage. There are other types of grids also, like one of the type is focused grid. Focused grid is made up of lead strips that are angled slightly so that they focus in space. A focused grid can be either a linear grid or a crossed grid. So here these focused grids are focused in space. This is not the actual diagram, but that's okay. So if you see, if the focus grid can be either linear or crossed grids. So if you see a focused grid, a linear grids will converge in a line, and this line is called as convergent line. So focus grids can be linear or crossed grid because the focusing refers to cross-sectional plane of the lead strips. The linear grids will converge at a line which is called as convergent line. So linear grids will focus at a line called as convergent line, whereas the crossed grids, so this is the convergent line where the linear grids will focus. So this part will focus at this point, this will focus at this point. So this is convergent line, whereas crossed grids converge at a point which is called as convergent point. Then the next terminology is focal distance. Focal distance is the perpendicular distance between the grid and the convergent point. So this distance between the grid and the convergent line or convergent point is called as focal distance. So in practice, the grids have a focusing range. So this focusing range mainly indicates the distance within the grid that can be used without the significant loss of primary radiation. The distance in which the grid can be used without the significant loss of primary radiation is called as focusing range. So this focusing range is fairly wide for low ratio grids and it is narrow for a high ratio grid. A 5:1, for example, 5:1 grid focused at 40 inches of focusing range has focused at 40 inches has a focusing, see, 5:1 grid focused at 40 inches has a focusing range of 28 to 72 inches, whereas 16:1 grid which is focused at 40 inches has a focusing range of around 38 to 42 inches. So these focusing ranges are also indicated on the top of the grids by the manufacturers. Then the next type of grid is a parallel grid. Parallel grid is the one in which the lead strips are parallel to each other when viewed in cross section. So these parallel grids are focused in at infinity so that they do not have any convergent line. These grids can be used effectively with either very small X-ray fields or long target to grid distances. They are frequently used in fluoroscopic spot film devices, but otherwise they are of little use in modern radiology. Lines per inch. Lines per inch is the number of lead strips per inch of the grid. So this lines per inch is calculated by adding the thickness of the lead strips and the interspaces divided by this sum by 1. So thickness of the lead strips d plus the thickness of the interspaces, and this is divided by 1. So because the thickness of the lead strips and interspaces is usually expressed in millimeters, so this answer should be multiplied by 25.4, which is millimeters per inch. So the final equation will be lines per inch is equal to, so this should be multiplied by 25.4. So 25.4 by the thickness of the lead strips and thickness of the interspaces. So then there is one more thing which is called as portable radiography. In portable radiography, there is a grid cassette or grid front cassette is a special X-ray technique which is used in portable radiography with a grid built in the front of the X-ray cassette. Most grid cassettes are focused grid and have a fairly low grid ratio of around 4:1 to 8:1. So these are the important points and terminology of grids. Thank you.